has one single lattice point. So yes, so another thing that book showed was that the concept of point effects and this deformality in polymers is also different to polymers, and the reason is that there is elasticity in these structures. The most common deformity in this material is screw dislocations. So yes, there could be a vacancy or interstitial, but the screw dislocations are the most common dislocation in polymers in this. There's another phase diagram that there is another concept which is like I've already discussed in crystallinity. So in the book, crystallinity is basically referred to as how much of a crystal it is. If it is much more organized and much more ordered, it will be much harder plastic. So basically, the polymers are divided in these three groups, and here is molecular weight. So as we increases the crystal structure, if it is the polymer gets more ordered and the molecular weight also increases, we have hard plastics here. Here we have much soft or liquid-like structures, and here we have multiple waxes that are also polymers. And one example that I just gave is polyethylene. So molecular weight here is basically like in polyethylene, the structure is much more simple. We only have ethylene structure and ethylene group and its repeated structures. But here we see that this molecule, this imide group here and this benzene, and so it's much heavier molecule than ethylene. So this contributes in its phase analysis, and when we increase the molecular weight of a polymer, it gets more and more hard. So this Kapton is much harder in terms of other, in comparison with other polymers, but it's much more lightweight.